transportation, people and goods on the move. Thank you for joining us in this after lunch session. What did you guys have for lunch? What are they serving here? Sausages and silence. Is it only sausages? Is there anything else? Schnitzel? Yeah? Anything else? That's it. All right, well, I'll look forward to that tomorrow. Where are you guys from? We're going to take a little poll. Raise your hand if you are from Germany. Yeah? Anybody not from Germany? Okay, where are you guys from? Spain? What else? Sweden? Netherlands? Hey, this front row is very international. I like that. Anybody not from Europe? You, sir? Mexico. Well, bienvenidos. Good. We are at the end of my Spanish knowledge, and hopefully everyone is done getting cabled up, and we are ready to go. I'll just throw a subtle link. Yes, okay, everyone has their microphone on. Let's start with what you came for, a panel on autonomous logistics. A warm welcome to our panel and our moderator. He's the editor-in-chief of DWZ, Deutsche Verkehrszeitung. Please welcome Sebastian, Reimann, and the whole panel.
By the time you get 10 up. Steering.
So, gentlemen, this is my seat. The other ones are all yours. Choose the best one for you. All right, gentlemen, I'm glad to have you up here on stage. Ladies and gentlemen, thank you very much for joining on our session on autonomous logistics. My name is Sebastian Reimann. I'm the editor-in-chief at DWZ. DWZ stands for Deutsche Verkehrszeitung, so we do all parts of transport and logistics, our special interest publication. And I'm very glad to host this session today. Well, let me introduce you my panel. Right next to me is Robert Ziegler. He used to be at A.T. Kearney. He worked for DHL. He worked for Wabaras, a big transportation company from Hungary. And he is now, let me see if I got it right. He is now, where are you? The General Manager Europe at Einride. Very good. Glad to have you here.
Thank you.
Next to him is Daniel Laury. He has worked for a lot of Silicon Valley companies. He's a multi-investor, and he is a co-founder and the CEO at Udelv from San Francisco. Great to have you here. Next one is Dr. Andree Hohm. He's the head of autonomous driving program at Continental, and you have worked for the company for like 12 years or something, so very experienced with the company. Great to have you here.
Thanks for having me.
Serkan Arslan, he's the Senior Vice President for Business and Partner Development at Apex.AI, a software company. You worked for a lot of companies, I saw that. Let me just check. You worked for Daimler, DT-Con, Delphi, NVIDIA, so you've been in the business for quite some time. Great to have you here.
Sometime, yes.
And from Amazon joins us Karthik Krishnan. He's the global head of strategy ADAS at Amazon Web Services. It's great to have you here. You come straight from the US. Great to have you here.
Thank you.
All right. Yeah, autonomous logistics, autonomous transportation. It's a huge topic here at IAA Transportation. It's a huge topic in the industry. Lots of expectations to be around that. Robert, what do you think? How far is the impact already of autonomous driving in the logistics industry?
Well, for us, logistics industry is actually an area that lends itself very much to autonomous transport. And we're able to fix lanes, we're able to fix environments that are easily controlled, and therefore we're able to move into actual commercial operations very quickly.
Yeah. Daniel, I mean, your company Udelv, what exactly are you doing, and why is autonomous transportation so important with your company?
Yeah, we're created the world's first autonomous delivery vehicle for public roads. And just recently in 2022 unveiled our prototype of our ultimate cabless generation vehicle. I think we are solving for two of the major problems of fleets today, which is number one, a massive shortage of drivers, and number two, electrification of fleets. We think that delivery is going to be the first large-scale application of autonomous vehicles because it's easier and safer to carry goods than it is to carry people. And we think that it is happening now. After multiple years of development, we're starting to see the first vehicles with no one behind the wheels in San Francisco, California, and the technology is becoming really mature and is happening now.
Robert, I mean, you have a similar approach, I would say. You also developed a vehicle that goes autonomous. How big is your range? What are you addressing in the transport and logistics industry?
Yeah, I think we have a similar philosophy, right? We also started immediately with a vision of an electric vehicle that is cabless. Why would you go autonomous with a cab? Right? Why would you still have a driver? So the driver sits somewhere else, but we're focusing on a different part of the transport chain. We're more focusing on the middle mile and heavy goods.
Yeah. Andree, Continental is a well-known company. It's a well-known supplier to the automotive industry. What is your approach towards autonomous transportation?
Yeah, so our approach is that we are providing a lot of the necessary puzzle pieces so that the visions of those two gentlemen can be industrialized at a certain point in time, yeah, because I mean, it's not just about having prototypes, about having 10, 20 or 50 vehicles driving around and everyone is happy that the steering wheel moves without someone has its hands on. But it's really important that we have an outlook how to put this in an industrial scale, yeah? And therefore you need products, you need components, you need systems, you need software which can be developed in automotive grade, automotive quality, and at the end also automotive cost, because I mean we are talking here about the IAA for commercial traffic, for commercial vehicles. So at the end to have a business case which makes sense commercially is very important, and our contribution is bringing in our whole knowledge and competency in terms of industrialization of all that.
Serkan, your part of the value chain is pretty much the software, the operating system. How do you look at the topic? What are the challenges? Where are the chances for you?
The whole industry is at the moment looking into software as the key driver for innovation. And software development has a different life cycle as vehicle development. So the challenge what we have at the moment is that the vehicles are developed in the traditional way, and software is developed in the modern way. And the only way to speed up catching new technologies is to find a standard, a common standard, which allows to really speed up developing. And what we have done is basically not reinvented the wheel. We looked into the industry and saw that ROS, Robot Operating System, has solved the problem already 10 years ago. So if you look into all the robotic systems, moving machines, factories, that industry has identified ROS, where there is a community who is working on a common standard. They developed the SDK, and the idea is similar to the phone industry like Android, that there is a set of SDK APIs which allows a continuous development. And I think that is the key here. If you would wait in the traditional approach until the vehicle is developed and then you launch it, then you have almost like a freeze. But in the commercial vehicle business, especially in the transportation and mobility, the vehicles are operated at least 10 years. So you need to make sure that you kind of enable the computer on wheels to be upgradable. In order to do so, there is a need to decouple hardware and software. And that's exactly what Apex.OS is, similar to ROS for robotics. Apex.OS is a safety-certified, automotive production-ready middleware. It's kind of a glue between the hardware and the software. And the software actually can be in the cloud as well as in the vehicle. So that's another thing. So in order to operate such commercial vehicles, it's not only to have a self-driving truck like Einride is operating, but it has to be connected to the operation center so the operators can manage And just imagine, and one of the challenges will be, so one thing is Einride is showing you can come up with autonomous trucks. So there is enough showcases outside. But if you're a logistics company, you usually have a mixed fleet. So you have different brands. So how do you handle if you have a Daimler Truck autonomous, Packer, Einride, all these vehicles, and how do you operate those in your fleet operation? And that's what we do actually.
Karthik, would you agree that there needs to be a certain way of standardization, and are you looking also to decouple software and the vehicle, or would you rather go the integrated way?
I think from our perspective, we have the software and hardware decoupling is important just to have an accelerated pace of development overall for what you want to launch as a vehicle. But the core aspect of vehicle development is still pretty challenging to accelerate just because of the safety requirements that you have in place, and the fact that the way you develop mechanical components it still requires you to do a lot of different types of analysis, testing, simulation, etc. before you can come up with the product. So if you can have something like Serkan said, where you can update the software or update the compute infrastructure within the vehicle, I think that's really valuable and can keep the vehicles relevant for a longer period of time, and you really replace more of the mechanical parts through wear and tear as expected. But we also have this other aspect of thinking about it from a data perspective, right? And looking to see how we can actually drive continuous improvement of the vehicle itself. If you have mixed fleets, if you have data from both the OEM as well as from operating these fleets, how can you do route optimization? How can you do better planning for the fleet that you have? Improve the longevity, reduce insurance costs. All of these factors start coming into play if you have more visibility into the data and how these autonomous fleets are going to be operated in the future.
Daniel, you founded Udelv 6 years ago, 5 years ago, and you have a vehicle, and I guess you have the software behind it as well. What was the harder part of it?
The hardest part of it was to invent a system that's never been done before to automate the tasks of the driver beyond driving, which basically is sorting out, first of all, loading the vehicle, then sorting out the packages, then taking a package, bringing it to the door, someone, going back to the vehicle, go to the next stop. If you think about autonomous delivery for the last and the middle mile, you have more than one stop. The moment you have more than one stop, you don't want the recipient of the good to be able to either have to find their package amongst 100 of them or to take somebody else's. So you need to come up with some sort of compartment system that is connected to the software that will allow each individual recipient to take their goods and not somebody else's. With our first generation, we came up with a system of fixed lockers and wheels. And we realized it didn't work because fixed lockers are either too big or too small for what you carry. So we went back to the drawing board, and after 6 months, invented something completely new, which is an adaptable shelving space where you can add or remove shelves depending on the size and the dimensions of the goods that you carry. So now we can carry 80% of the goods for last and middle mile. And then we had to change the doors because you have fixed doors. It'll open on nothing or it'll open on too many shelves. So we created a system of horizontal sliding doors and vertical sliding doors we call the iris that creates a rectangle anywhere on the surface of this. It's all controlled by software, and it opens only on your compartment or a set of compartments. So now we can deliver as tires for a tire manufacturers, as well as groceries for a grocery shop. And that's what's taken a lot of time to create, invent, test. We tested this over 20,000 deliveries in our second generation vehicle with Walmart in Phoenix, Arizona, with the Excellent Parts and Auto Parts distributor in Texas, and then finally came up with a system that we now have our prototype of the third generation, which is a cabless vehicle that's never been done before.
So with your vehicle, there is no human being on board, around it, or anything. It's just a vehicle that comes up and somebody can pick up its package.
Correct. So we created the vehicle, we created the rolling chassis, basically the pod that sits on top of it that's detachable. So the pod can carry up to 2,000 pounds of cargo, about 1 ton of cargo, which is very, very sizable. Can make up to 80 stops in one run, which is the largest ever in the world. And if you remove the pod, you can strap on goods on the flatbed, and now you can carry up to 5,000 pounds of cargo at 2.5 tons, which is extremely versatile. First time in the world that we create a vehicle like that. It's augmented by perhaps one of the world's best teleoperation system to remote control the vehicle and potentially drive the vehicle in unmapped areas and with a latency of what we call glass-to-glass of less than 100 milliseconds. For the autonomous driver, we partner with Intel's Mobileye to make the vehicle drive. We think is one of the best autonomous drivers in the world.
Robert, I think with Einride, there is at least the opportunity for a remote driver still there, right? I mean, you haven't cut out the human being totally.
Yeah, that's clearly part of the concept, right? We still come into situations, in complex traffic situations, that you need a human in the loop. And since we don't have a human on the vehicle, we have a human remotely that's supervising the autonomous operation, but who can also intervene into the operation. The advantage of having the human in a different place is, first of all, they don't have to sit in the truck, right? And so it's a different environment that they work on, which is a lot more pleasant. And they can supervise multiple vehicles. So we can actually create a cost advantage by taking the driver out of the equation of the transportation bill.
Mm-hmm. Andree, I mean, is that the big challenge to get autonomous driving vehicles plus vehicles that are driven by human beings in one road network, kind of?
Yeah, I think at the end it's always important. There are many viable application areas of driverless vehicles. Yeah? I mean, having a driverless truck on a road network which is driving 5,000 miles through the US from one hub to the other has certainly totally different requirements compared to, let's say, a food delivery service autonomous in New York City. Yeah, so it's super different. Yeah, and I think all of these approaches make a lot of sense in their respective area. Yeah? Talking about having big freight operations in a driverless way around the world, for sure you have to share somehow the road space, yeah, because no one will create a totally new road network all around the world just because there are some companies now coming up and say, hey, we can also have some of these trucks autonomous, so you have to build separate roads for them. So the operational domain of these areas is the normal traffic infrastructure which we have today, also including other manually driven vehicles. Yeah, they have to be taken into account. So this is just what you have to live with. Yeah. If there are other approaches where, for example, you have operations within big logistics centers where today there is a lot of human effort just driving boring things around, yeah, so it's not super complex to do that, but there it's much easier to say you switch one logistic hub from one day to the other just to autonomous operation. Yeah? So the operator of that center just has to decide that, everything can be prepared. Maybe even if a new center is built up, that can be considered from day one of the construction. And so you can really make that fully autonomous, where you adapt everything around to that autonomous operation. So long story short, at the end, it's really very different if you take a look about those different operational areas. And this is also defining your technical degrees of freedom, what you have to take into account, and what is really the degree of freedom which you can shape.
Serkan, what are the next use cases you see down the road? Where will autonomous transportation be used? Are we still on the stage where it is in a secure area like a fabric or something, or is it already really on the public roads now?
Difficult question, because the commercial vehicle industry is so broad. The use cases are farming, construction, public transportation, container swapping warehouses. So the benefit is obviously in the commercial area the biggest. Time is money. Employees, there is a lack of stuff. So the pressure is there. And what we see already at the moment is that in all these off-roads, less critical, less safety critical areas, there is already autonomous driving in place. And if you have the container harbors, it's already autonomous. If you ask on the public roads, that is a very optimistic scenario was 22, which didn't happen. So the next generation of vehicles have been started now, which means probably 24, 25, we will see first pilot fleets driving on highway, level 4, hub to hub. There are already a lot of trucks driving now, but what I'm talking about is the production. So there is a production ready where customers like DHL or Penske can order from the car maker that truck. Those trucks will be probably, the first ones will be in 25. But the challenge, coming back to my previous topic, is that the commercial industry has to come up with a continuous improvement and development. So there needs to be a platform where over the lifetime of a truck, the truck owners can go to the garage and change the computer or change the sensors or the cameras and upgrade the truck to do new features. So there will be new features coming in, but what we have to do now is to enable the platform. Platform is hardware and software, so it can be upgraded in future. And that's what at the moment everyone is trying to do. And the truck industry is really significantly more complicated than passenger cars, because cars drive on roads. You have the perception stack can be trained because it's very similar, but on a truck, it is a garbage collection, it's a street cleaner. So the use cases are so different that for each use case, there needs to be a space and a spare room and a freedom to come up with new features over the lifetime. So what I see is once the base is settled, the framework, the tools, the abstraction, the number of innovations will explode. At the moment, like Einride, everyone has to, or Udelv, everyone has to develop really from scratch the vehicle, the base software, the connectivity to the cloud, the application itself. That is a huge effort. So that's going to hopefully change very soon.
Karthik, what do you see as the next steps, especially for Amazon? I mean, your company is a big system in itself, kind of. You have a huge fleet of delivery cars, etc. Is that pretty much the next step for you to really get them autonomous, or what are you heading at?
Yeah, so we have two things, right? So one is on the Amazon side, logistics and delivery times matter, right? If we want to meet the requirements with what we have with our prime numbers, and we want to do same-day delivery or want to accelerate that, we definitely are constantly looking at the technologies that are in the market today and seeing where we can take advantage or leverage what's being done in the R&D space and also what's getting commercialized. And at the same time, on the other side, with what we have on the cloud, on AWS, we're looking at how we can get these fleets to be more connected. How can we leverage that data? What have we learned from all of the work that we've done in the retail space in terms of being able to deliver the products that we deliver today? And how can we use that to help improve overall fleet performance? And where can autonomy actually help? Like we've already mentioned, there'll be mixed fleets. There'll be companies that'll have partially human-driven fleets and partially autonomous fleets as well, right? So how do we then look at that as a system, at a system level overall, and make that more effective and efficient? And this ties into what we see as infrastructure modernization that is also happening in a lot of places. So are there going to be opportunities to have more vehicles connected to the smart road infrastructure, smart grids, and how can we leverage that as well to make a more efficient, connected ecosystem?
Daniel, when we talked before the session, you said pretty much this whole technology, this whole topic is further down the road than a lot of people think. It's happening faster than a lot of people think. Why is that, from your point of view?
I think that the way the industry evolved is in 2017 there started to be a lot of hype about around the technology, thinking it was going to happen soon. By the way, in 2017, it's already been 10 years that Google had been working on this since the Grand DARPA Challenge in 2007. So when Google is working on something for a total of 10 years, there's a lot of progress being made. But in 2017, we thought it was going to be for 2018. 2018, we thought it was going to be for 2019, and then it didn't happen. So now we're at a time where people start doubting about the technology and thinking, well, it's going to be the end of the decade or maybe 2035 or something like that. In fact, now we're at the time that is taking off and that it's maturing. And I drive every day through San Francisco to my office, and today I see every day a cruise vehicle, which is General Motors, driving in San Francisco with no one behind the wheel. And for me, who's been in this business for the last 5 years, it's still magic. And this has been happening for the last 3 months. So you really you have vehicles that have passengers in the back seat, no one behind the wheel driving through San Francisco. And that's for Cruise, that's for Waymo. It is happening now. Mobileye is, I think last week, announced the deployment of 50 vehicles that are going to be driverless in Detroit. So it is really coming by the time that we get into 23, 24, barring any supply chain issues, which is slowing down the industry, but that has nothing to do with autonomy. It is absolutely coming. The second thing I would like to mention is related to your prior question, is where is this going to happen first? I think in the delivery space. I think it's going to happen first where the cost of the driver is the highest portion of a run, of a deliver run. And the highest portion is last and middle mile, where you have a lot of stops and you're delivering individual packages to each one of those stops. The driver represents about 60 to 65% of the cost of a delivery in those segments. And that's where you have the greatest chance of having an affordable driverless system that can compete with a driver system. And I think that's where it's going to start. And I also think that it's going to start where people don't necessarily think it will, which is the B2B space first, because it's easier to go from a place where you have a professional loading to another place where the professional is unloading the vehicle. And most of the times, those are loops that are repeated 3, 4, 5, 6 times in a day. If you take the auto parts distribution industry in the United States, for example, which is massive, $700 billion, the five largest auto parts distributors operate more than 200,000 vehicles. They're operating loops from a distribution center to store number 1, store number 2, store number 3, back to the distribution center 4, 5, 6, 7 times a day. These are and those are in suburban areas, suburban Houston, suburban Dallas, where it's easier. You have less pedestrians, less traffic. The roads are straight, well marked. I think this is where this is all going to start on a delivery space.
Robert, would you agree? And what are the biggest challenges you hear from your customers? I mean, you work with Schenker and a couple of other companies from the logistics industry, I think.
Yeah, I think we've been operational since 2019. We have licenses in the US to operate in public roads. We have licenses in Sweden to operate in public roads now. And this is not prototypical anymore. We're driving commercial transport on fixed lanes within certain fixed environments. And yes, we still had to build the hardware ourselves, and we still had to build the software ourselves. But that's the name of the game. We're basically not an OEM. We're a transportation company because we need to deliver the whole ecosystem. The individual parts of the ecosystem are not compatible to each other at the moment. So you need to build the whole thing. You cannot say, oh, here's a chicken, I need an egg, or here's an egg, I need a chicken. You need to make an omelet and move on. And that's basically what we're doing. We're building these solutions for our customers. We're putting them in place, and they run 24/7 because the truck doesn't have to take a break except for charging, and you do that at loading and unloading, and then you basically have an operation that really has a cost reduction and really delivers the kind of benefits to industry that they need.
I mean, cost reduction is, of course, a big driver for things like that. What can we think of? How much can it really bring to the system of cost reduction?
I think you've mentioned it. It depends a little bit on the labor cost part of your value chain. In the middle mile, it's 30–40%. In the last mile, it's probably a little bit more. So that's quite a good advantage. That's quite a good change for a transportation industry that is really riddled with a lot of changes lately, a lot of volatility and cost that is driving towards sustainability at the same time, which adds cost here and there. So to be able to also find areas where you can actually reduce the cost, be competitive with the diesel fleets that are out there today with drivers, is a very important argument for the customers.
Andree, if you look at some other challenges, of course there are security issues. We all know these news about something happening with an autonomous driving car or something like that. Then we have the whole topic of regulation. I mean, here in Germany, we were proud and announced we want to be the first regarding regulation. I don't know if that really happened. Maybe some doubts could be there. What do you see from that side, security, regulation, as the biggest challenges?
Yeah, so I mean, security is definitely a topic, but it's not restricted to autonomous driving. Maybe you saw some of these experiments by nice IT guys, yeah, where they hacked existing vehicles and could actuate steering wheels and so on. Yeah, so this is really something which is a technological challenge which we are facing right now in the automotive industry. Yeah, all over the whole scope of commercial vehicles and also from passenger cars. Yeah. And I mean, there we are currently working on creating mechanisms to make those things safer. Yeah, the players from the traditional automotive industry trying that. Yeah, but of course there are also new companies which are building up competencies around especially that. And both things have to be put together really to make those things waterproof, so to speak. Yeah, so. We see in comparison many other industries which are also in theory very sensitive to security issues. Yeah, if you take a look about aviation, for example. So it can be done. Yeah, it is not say that if you say, oh, there's a big risk and we cannot do that. Yeah, there is a lot of things you can do with technical measures, and those technical measures are proven in other industries. So we have to incorporate them also to autonomous vehicles. So super complicated, but this is a problem which in my view is solvable, and there are solutions on the table how that can be done. The second topic, regulation. I mean, if the question is if this is a main hindrance currently, I would not say that this is the case. Yeah. I mean, we have a lot of degrees of freedom for experimentations. Yeah, so I mean, you talked about you have some licenses and so on. So typically, if you can put something on the table where you say, this is working, and you can give the proof that it is safe, even though it's a prototype, normally you are talking to reasonable people from the authorities, and they say, okay, so if you give me that proof, I have no reason to stop any operation of that. So this is fine. For the commercial operation, I think also there are a lot of initiatives in place, yeah, so coming, for example, from the UNECE technical regulations, which are moving slowly but in the right direction forward. We have initiatives like in Germany with a level 4 law, which is actually in place, yeah, so you could use that for introducing a commercial operation of driverless cars on the road, so it has happened, yeah. So everything works in the right direction, maybe some things a little bit too slow, and I think there is still some time left. I mean, Serkan, you named that the center of expectation of bigger driverless operations is around 24. I see that also in that time frame. So what we have to make sure is that the the legal framework is ready in time. Yeah? So we have to work here in the background so that if these systems really can be rolled out in a bigger scale, that the hindrance is not now in 3 years, that everyone is ready with the right technology, everything works perfectly, but it cannot be deployed on the road. Yeah? That has to be avoided at any cost.
Serkan, if we come back to your point of standardization, will that eventually come through cooperation between companies? Something will just make its way through, or does it need regulation for that as well?
Regulation is important for safety purposes, but in order to force the industry to work on a standard, that idea never worked out in the past. It takes way too long. So standardization usually happens by acceptance. And acceptance means if something is proven, it's good, it's developer friendly, it solves the problem, then it will be applied by users, in that case either vehicle makers or the service operators, and then it becomes a kind of a de facto standard. And that is exactly what we are at the moment trying to do. Is we have these two types of customers: the ones who produce the vehicles, develop the vehicles. That could be a truck, it could be a aviation, eVTOL, it could be a rail, delivery robots. It doesn't matter what, on water. So any kind of those vehicles. In that case, we are providing the vehicle OS, which allows to deploy as soon as things are ready. So if the software is ready, you deploy it. If the regulation is ready, you activate it. And on the other side, what we also do is we support the MAS, Mobility as a Service, and TAS, Transportation as a Service operators with an operating system which allows them to do the same. So they have an operation center, usually connected via cloud. AWS is certainly in that game. And it's connected to the vehicles, to the clients, to the edge. And that needs to be also updatable over the lifetime. So the current problem is a vehicle takes 7 years still to be developed. It's too long, too costly. It requires hundreds of people to develop a piece of software. Once someone comes in and shows that it can be done with 1/10 of that, then the industry will jump on it. Usually, the first ones who jump on it are more the entrepreneurs, so the ones who take some risk. And then once it's proven, more and more will follow. So what we will see is in the next few years that there will be new technologies deployed in vehicles, and then others who are a little more conservative will realize, okay, it looks like it works, and then they will adopt it. And that is basically our business model. So we have started with large OEMs, truck and vehicle OEMs. You will see the results in a few years on the roads. And once that is proven, all the others will follow. And that is our hope. At the end, the differentiating is not done on a base software. It's done on the feature on top of it. So the vehicle, HMI, the UI, the user experience, and the function itself. And that's why if everyone would agree on the same glue, the same API, then there is a big chance that the cost will go down because it becomes like plug and play. So if someone develops a perception stack, it runs on the same platform as someone is developing a function which is completely different. So I think the key here is acceptance will define it, the developer experience will define, and the speed. Software is about speed. So the ones who can achieve the same results in a shorter time with less efforts, that technology will dominate.
Karthik, I mean,
Yeah.
we just talked about the cost, and of course we have rising costs in the supply chains. It's very expensive these days. Will that eventually speed up the development of autonomous logistics, autonomous driving, because there is need for more efficiency, cutting down costs, etc.?
At the initial part of it, no, because if you take a look at a vehicle that's driven by humans today, and now you start adding the additional software layer, the additional sensor stack, that all increases the overall, let's say, bill of materials and cost, right? And the vehicle themselves are transforming as we speak towards electrified or hydrogen powered and so on. So that is those new types of vehicles typically also tend to be more expensive. But over time, I think that cost will be amortized and you will get into something that will give you economies of scale and you'll be able to do it at a much lower cost. But at the beginning, there will be a spike in cost as we are transitioning, as the fleet managers and as companies are transitioning from traditional mobility to e-mobility, and at the same time moving from drivers that drive vehicles today with some kind of safety assistance, like driver assistance systems that are in place to keep the vehicle safe, right? So reduce accidents, and so that way to kind of reduce cost as well, and improve your margins, to eventually going to full autonomy. And again, full autonomy is not guaranteed in all circumstances and in all domains, right? In places where the infrastructure is fairly well established, your lanes and your roads are fairly, clear, and everything is, all the traffic signs are clearly readable. Yes, the autonomy capabilities will be deployed there, and you can start generating some revenue from that. But deploy it at a global scale across different countries, different regulations. That's going to take a lot more time.
Ladies and gentlemen, I would like to open up the panel for your questions, if you have any. So if we have any questions or comments, they're very welcome. No questions at all? All right, then I'll just go on with my questions. Robert, maybe if we would go into one final topic now. I mean, we've talked about autonomous transportation. The name of the session is autonomous logistics, so there's a lot more than just the road transport, for example. I mean, we have warehouses where lots of robots, etc., all these kind of things. Do you see really an autonomous logistics not too far down the road, where everything kind of intermingles?
Yeah, definitely. I mean, in autonomous warehousing, you see a lot of development, right? I mean, things are in a much higher stage. Obviously, you can manage a warehouse with robots much more efficiently, much more effectively. Use every nudge and cranny and every space in the warehouse much better. So autonomy in the warehouse has a big role. It is also a lot more advanced now. I mean, we've experimented with this for 30, 40 years in the logistics industry. And in the past, there used to be, bulky metal things like, pallet robots that would break down and then you couldn't get the pallets out and things like that. Now these are distributed systems that are independent, so one breaks down, another one takes over. It's more of a package kind of logic rather than a big infrastructure installation. There's a lot going on there, and that is amazing. I think as we're going to become more autonomous also on the streets, we have to also think about the interfaces, and we're working with some of our colleagues who already have very highly automated factories. We're working with them now also on autonomous loading systems to basically charge and decharge the truck faster, more safely. I mean, actually the docking exercise, and I know this from my own experience, that the docking exercise is one of the most dangerous moments that you're doing in logistics. And you don't necessarily want people involved with that, right, for safety reasons. So it's super important we get that right, and then we actually have the loading process also automated. And with that, and then looking at the last mile distribution, the kind of things that Udelv is doing, that is where we then can basically, connect all of the dots from the factory to the consumer, and it could all be autonomous eventually.
Karthik, maybe to sum it up, is that something you already try out at Amazon to really get the different things, the warehouses, the transportation, autonomous and connected?
Yeah, so if you go to any of our fulfillment centers, our warehouses are very highly automated today, already, with both on the sorting side as well as on moving the different packages to the right place. And we have pallets that, the machines that move the pallets are also fairly automated as well. So we're already getting there internally within our warehouses. We have a lot of automation in place. And the next step is now the delivery of the goods and also getting from, even from a single distribution center, from a single warehouse to other distribution centers locally. So you can start moving those goods to the end customers in a faster way. So we are working on that as well. And again, a big part of that for us here, at least, is using the cloud to understand where and how we can continue optimization in the space as well. So having visibility, having the data on a regular basis, a constant stream of it in real time, helps us make those decisions and helps us kind of drive that automation forward.
Well, gentlemen, I think we have to come to an end. We've dug a toe into the whole ocean of autonomous driving, autonomous transportation, autonomous logistics. Maybe next step then is kind of that the cargo is really steering itself autonomously through the whole system. We see if that happens one day. But for now, thank you very much for your insight. It was very interesting. Thank you.
Thank you.
And thanks for you as well for joining our session today. And well, have a lot of fun at the IAA Transportation. Thank you very much.
Thank you, Sebastian.
Thank you.
You are welcome to come back anytime. You always finish on time. That was so interesting. I really appreciate it. And I hope you guys have a lovely afternoon, moving people and goods.
Thank you very much. All right, gentlemen, thank you.
If you're joining us on the web stream, we are going to take a very short 15-minute break. If you're here in the room with us, you're welcome to stay, grab a coffee, talk to your neighbor. In 15 minutes, we are continuing on with a keynote from Sean Kerrigan. He's going to be talking about autonomous driving at